Echoes of Eternity. Humanity's epic journey to the edge of the universe and beyond. Ever found yourself gazing up at the night sky, wondering about all those twinkling lights? I mean, have you ever really looked at the stars and thought, what's out there? Since ancient times, we've been captivated by that endless canvas above us. So today, let's embark on an epic journey together, from our earliest stargazing ancestors to venturing beyond the edge of the universe as we know it. Buckle up, it's gonna be an incredible ride. Ancient stargazers, picture this. Thousands of years ago, our ancestors are sitting around a fire, no smartphones, no city lights, just them and the vast, glittering night sky. Back then, the stars weren't just distant suns, they were mysterious and powerful, maybe even divine. Early humans probably looked up and connected the dots, quite literally, forming shapes and patterns. These were the first constellations, serving as both stories and guides. Mythology and the cosmos. Different cultures across the world wove incredible myths around the stars. The Greeks had Orion the hunter, the Egyptians revered Sirius, the dog star, and in Chinese mythology, the stars told tales of dragons and celestial emperors. These stories weren't just entertainment, they were a way to make sense of the universe, to explain the unexplainable. It's amazing how looking up at the same sky inspired such diverse legends. First astronomical observations. Then came the ancient structures aligned with celestial events. Think Stonehenge in England or the pyramids of Giza. These weren't just architectural feats, they were astronomical instruments. Stonehenge, for instance, aligns with the solstices, acting like a giant calendar. Imagine building that without modern tools, all to track the seasons and the stars. Revolutionary thinkers. Fast forward to ancient Greece. Philosophers like Aristotle were pondering big questions about our place in the cosmos. He championed the geocentric model, the idea that Earth is at the center of the universe. It made sense at the time. After all, we don't feel the Earth moving, and everything seems to revolve around us. The heliocentric shift. But then along came Nicolaus Copernicus in the 16th century, who proposed something radical. What if the sun is at the center and we orbit around it? This heliocentric model was a game-changer. It challenged long-held beliefs and shook the foundations of both science and religion. It was like suggesting that the Earth wasn't the VIP of the universe anymore. Galileo's telescope. Enter Galileo Galilei, a scientist with a knack for stirring the pot. He didn't invent the telescope, but he sure made good use of it. By observing the moons of Jupiter and the phases of Venus, he found strong evidence supporting Copernicus's heliocentric model. Of course, this didn't sit well with everyone, especially the church. Mapping the heavens. Galileo ended up under house arrest, but his discoveries couldn't be unseen. He was a true pioneer, pushing the boundaries despite the risks. Johannes Kepler built on the work of his predecessors to develop his laws of planetary motion. He figured out that planets orbit the sun in ellipses, not perfect circles. This was huge. Newton's law of universal gravitation. It explained the weird paths that planets seem to take across the sky, no more head scratching over retrograde motion. Then comes Sir Isaac Newton, who essentially said, hey, I can explain all this with gravity. An apple falls from a tree, and suddenly he's formulating the laws that govern the entire universe. Advancements in telescopic technology. His law of universal gravitation explained why planets stay in orbit and how objects interact with each other in space. As our understanding grew, so did our tools. Telescopes evolved from simple lenses to complex mirrors, allowing us to see farther and clearer. William Herschel even discovered Uranus in 1781. The space race era. Post-World War II, the world was in a technological boom, especially in rocketry. Both the USA and the Soviet Union were eager to take these advancements to new heights. The competition was fierce, but it spurred incredible progress. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite. Launch of Sputnik. It was a metal sphere, about the size of a beach ball, orbiting Earth and sending out radio beeps. Simple, yet groundbreaking. This event ignited the space race and made everyone sit up and pay attention. Yuri Gagarin became the first human in space in 1961, a monumental achievement for humanity. First humans in space. Then, in 1969, the Apollo 11 mission put Neil Armstrong and Buzz Aldrin on the moon. That's one small step for man, one giant leap for mankind. Those words still give me chills. These milestones weren't just about national pride, they represented the limitless potential of human ingenuity. Pioneer and Voyager missions. While manned missions captured headlines, unmanned probes were making extraordinary journeys. The Pioneer and Voyager missions set out to explore the outer planets. Voyager 1 and 2 gave us our first close-up images of Jupiter, Saturn, Uranus, and Neptune. And here's the kicker. Voyager 1 is now in interstellar space, carrying the golden record. Mars exploration. Mars has always been the subject of fascination. With its reddish hue visible from Earth, we've long wondered if it's a neighbor harboring life. From the Viking landers in the 70s to the sophisticated rovers like Curiosity and Perseverance, we've been exploring the Martian surface. We've found signs of ancient riverbeds and minerals that form in the presence of water. Saturn and beyond. The possibility that Mars once had conditions suitable for life is incredibly exciting. The Cassini-Huygens mission expanded our knowledge of the Saturnian system. Cassini orbited Saturn, sending back stunning images of its rings and moons. The Huygens probe landed on Titan, revealing lakes of liquid methane and ethane. Unveiling the universe. Launched in 1990, the Hubble Space Telescope has been like the ultimate window to the universe. Despite a shaky start with a flawed mirror, once corrected, it provided images that are both scientifically valuable and breathtakingly beautiful. From the pillars of creation to distant galaxies, Hubble has shown us sights that were previously unimaginable. Understanding the Big Bang. Through observations, we've gathered evidence supporting the Big Bang theory. The discovery of the cosmic microwave background radiation, the afterglow of the Big Bang, was like finding a photo album from the universe's infancy. Plus, the observation that galaxies are moving away from us, redshift, supports the idea that the universe is expanding. Dark matter and dark energy. But it's not all figured out. We know that visible matter accounts for a tiny fraction of the universe's total mass energy content. The rest is dark matter and dark energy, terms for stuff we can't directly observe but know must exist due to gravitational effects and the accelerated expansion of the universe. Searching for exoplanets. The Kepler Space Telescope revolutionized our search for planets beyond our solar system. It monitored over 150,000 stars and discovered thousands of exoplanets. Some of these are Earth-sized and located in the habitable zone, the sweet spot where liquid water could exist. Detecting exoplanets is like trying to spot a fly next to a lighthouse from miles away. Methods of detection. Astronomers are clever. They use methods like the transit method, observing tiny dips in a star's brightness when a planet crosses in front, and the radial velocity method, detecting wobbles in a star due to a planet's gravitational pull. This brings us to the big question. Are we alone? The possibility of life beyond Earth. With so many planets out there, the odds of life existing elsewhere increase. Projects like SETI are actively listening for signals from intelligent civilizations. The discovery of microbial life, even simple organisms, on another planet would be one of the most profound discoveries ever. The edge of the universe. The universe is about 13.8 billion years old, but because space itself is expanding, the observable universe stretches about 93 billion light-years in diameter. Beyond that, we can't see. Light from those regions hasn't had time to reach us. The cosmic horizon is like the ultimate final frontier. Cosmic horizon. What's beyond it? More galaxies? Different laws of physics? It's one of the most intriguing questions in cosmology. Some theories suggest our universe might be just one bubble in an infinite multiverse. Each universe could have different physical constants or dimensions. It's a mind-bending idea, but it could explain some of the peculiarities we observe. Multiverse theory. Then there are concepts like wormholes, hypothetical tunnels connecting distant points in spacetime. While they're still in the realm of theory and sci-fi, they represent the ultimate dream of faster-than-light travel. Imagine zipping across the galaxy in the blink of an eye. Future of space exploration. The James Webb Space Telescope is set to be the next big thing. With its advanced technology, it'll look back to the universe's first galaxies, studying how stars and planets form. It's like having a time machine. Plans for human missions to Mars are becoming more concrete. Human missions to Mars and beyond. NASA's Artemis program aims to return humans to the moon as a stepping stone. Private companies like SpaceX are developing spacecraft designed for Mars colonization. The idea of humans becoming a multiplanetary species is edging closer to reality. But it's not easy. Challenges of long-duration space travel. Astronauts will face radiation exposure, psychological stresses from isolation, and physical health issues due to zero gravity. Solving these challenges is crucial for successful long-term missions. Terraforming Mars, transforming it to resemble Earth, is a massive undertaking. Colonization and terraforming. It involves altering the atmosphere, temperature, and ecology. While the concept is exciting, it raises ethical questions about altering another planet. To reach distant destinations, we're exploring new propulsion technologies. Ion drives offer efficient, albeit slow, acceleration suitable for long-duration missions. Advancements in propulsion. Concepts like nuclear thermal propulsion could significantly cut travel times. And then there's the idea of antimatter engines, still theoretical but incredibly powerful. AI is becoming indispensable in space exploration. Autonomous robots can conduct experiments, make decisions, and adapt to unexpected situations. Artificial intelligence and robotics. Rovers like Perseverance on Mars are packed with advanced tech, including AI to help navigate the terrain. Asteroids are rich in valuable minerals and metals. Mining them could provide resources for space infrastructure and even support Earth's economies. Companies are seriously investing in this potential. Asteroid mining. Space exploration is a global effort. The International Space Station is a prime example, with 15 nations collaborating. Joint missions pool resources, share knowledge, and foster peaceful relations. It's a reminder that when it comes to exploring the cosmos, we're all on the same team. Philosophical reflections. When you think about the vastness of the universe, it's both humbling and awe-inspiring. We're tiny specks on a small planet, yet capable of understanding and exploring the cosmos. Seeing Earth from space underscores its beauty and fragility. It drives home the importance of taking care of our planet. The human spirit of exploration. After all, it's our only home, for now. There's something innate in us that seeks to explore, to understand the unknown. It's driven us across oceans, to the poles, and now into space. This spirit propels us forward. What we achieve today lays the groundwork for future generations. Legacy for future generations. Kids growing up now might be the first to live on another planet or discover life beyond Earth. From ancient stargazers to modern-day space explorers, humanity's journey through the cosmos reflects our relentless curiosity and drive to understand. Our explorations are the echoes that will resonate through time. Echoes of eternity. Each discovery opens new doors, leading us further into the unknown. So let's keep exploring, questioning, and dreaming. The universe is vast, but so is our capacity for wonder. Whether you're an aspiring astronaut, a backyard astronomer, or someone who just loves a good sci-fi flick, your curiosity fuels the future. The universe is vast, but so is human curiosity. Our journey is just beginning. Thanks for joining me on this incredible adventure. Until next time, keep looking up and stay curious.